an intro to my YouTube channel yet.
I don't have enough panther bucks.
Okay. Well, I have one of my 8th graders has like 60.
What is it? Is that for him?
No, it's Michael.
Michael McHenry?
Yeah, and he's saving up so he doesn't have to go to time to teach on the last day of school. Because like apparently it's like 2 panther bucks for 2 minutes out of time to teach, or something like that.
What?
Oh,
Seriously?
Yeah,
yeah.
it's like some weird exchange rate. Yeah, the boarding. Okay, so let's say that I know.
How would he just get the hour-long lunch?
I know. I don't know. I don't know. It doesn't make any sense.
Just ask him that. Why don't
I've brought it up with him.
I spend too many panther bucks on writing dumb boards.
Okay. Yeah, and I'm gonna erase it because you didn't pay for it. So let's say that you're walking to school one morning.
in rectangular?
Well, hold on. I'm going to explain the rectangular prism in a second here. Just settle down. So this is you're balloon man, and you're walking to school one morning, and it's real misty out. There's all these dots of mist. Super, super misty. Okay? Mist is hanging in the air like pea soup. Have you guys ever heard that it's not a metaphor, that's simile?
No.
Okay. Like some sort of chowder. And so let's say that there's 0.02 ounces of water per cubic foot. All right. So you're going to walk forward 50 feet. And you just make some calculations on the fly, and you estimate that your body, the surface area of the front of your body, so, the surface area of the front of your body is roughly 8 square feet. So like if you were to like just put wrapping paper on the front of your body, it would be roughly 8 square feet. Okay?
Small.
I can. You want to know about how much water you're going to collect on your clothes when you walk these 50 feet.
The surface area.
So like the surface area of the front of your body. Like if you were to wrap the front of your body in wrapping paper, it would take 8 square feet of wrapping paper. Okay? The front of your body. If I were to peel off the skin of the front of your body,
There you go.
it would be 8 square feet of skin. Excellent question. I'll leave that up to you. Okay. So, as you're walking, so you're walking. When you reach the end of the 50 square feet, your body is going to be covered in water, and you want to know exactly how much water did you pick up from this misty, misty, misty air from walking through it.
By 50, 8 square feet.
So we're going to do 8 square feet, so 8 feet squared times 50 feet.
And then times 0.02 ounces.
So that's 400 cubic feet, right?
Yep.
And then we're going to take whatever that is and multiply it by what? 0.02, and that's ounces per cubic foot, per foot cubed. Now what's going to happen to the units with this?
It's going to be ounces.
So the cubic feet cancel, and what's 400 divided by 0.02?
400 times.
Or sorry, 400 times 0.02, you're right. Okay. We enslaved an entire race of machines to do this for us. 8. And 8 what? 8 ounces. So over this 50 feet that you've walked, you've accumulated 8 ounces of water on top of your body. Okay? Does this make sense?
Yep.
So this is kind of, just to remind you guys, this is how, well, first question, does the speed in which you walk matter? Okay, James says no. Well, less time, but does it matter about how much water you pick up on your clothes?
It's, well, if you were collecting it either way, it's the same amount of water.
So if you
It's
run,
like if you jump in a pool and run, and swim 50 feet and get out, no matter how fast you swim it, you're still gonna have that much water on your body at the time when you jump out of the pool.
okay,
It's like
Is that the right
coming on you, so like if you were to stand in one spot,
mm-hmm.
you would be traveling zero distance, but you would still be soaked if you were there for like 30 minutes. You know
So-
what I mean?
So my question is, you're traveling this 50 feet, so you're not doing zero. So you're always going to be traveling this 50 feet. So my question is, would you get 8 ounces of liquid on your clothes if you like did a turtle walk this 50 feet, or if you did like an all-out sprint this 50 feet? Would it matter? Like, would it change this 8 ounces that's going to be on your clothes?
Not if it was just
Well,
like
you
a
didn't,
miss.
you didn't take into account for time in the original answers. I don't feel like you would,
Okay.
where would you put time in there to make it affect the answer?
Yeah, in the word problem, there was nothing about how long it took to get 0.20 ounces.
Yeah, that's what.
Okay.
If you said if it took you 0.02, or you got 0.02 ounces of water per cubic foot traveling at 1 foot per second, and you said you got 0.001 traveling at 3 feet per second,
Mm-hmm.
it would be, then
Okay.
time would matter, but where you didn't put that in the problem, I don't think time would matter.
So Maria and James say time doesn't matter. Brody, you said time does matter. Why?
Because, well, like, the longer you are in a mist, like, say that that's like a sprint to your door, and
Mhm.
after the 50 feet, then you're going inside. Well, the longer that you're out there, the more time the water has to settle on you because it's a mist, so the water's already there, it's gonna get on you either way. The amount of time that you're out there is gonna affect how much water you collect as well.
Hmm.
Also, the absorbency of your clothes does matter.
The what?
The absorbency of your clothes.
Okay, the absorbency of your clothes. I see your argument with that. So like maybe if you scotch guarded yourself up real good before you went out,
Or if you had,
Had
or if you had a
Rain
rain
poncho.
slicker.
a
on-
poncho, a slicker, okay.
Areas it just matters too.
Yep.
I see your argument with that. Okay, so this is pretty much how volume in general matters.
There's no force applied that you put your car in, if you're coasting
Why,
in your car.
why does your board have the ghost of Illuminati confirmed?
Because of Adam was in here earlier. Okay, so if you want to find volume of pretty much any three-dimensional solid, it's almost the exact same formula so long as it's what's called a right three-dimensional solid. So long as the base is perpendicular to the height, which is what you've dealt with up until this point. So now that we're in calculus, we can start dealing with solids where the base is not perpendicular to the height. But just to remind you how to do that, so if this is a cylinder, the base would be, what's the area of the base of a cylinder?
Pi r squared.
Pi r squared. And then you would take that and multiply it by the height. So pi r squared times height would be the formula for volume of a cylinder. So essentially what you're doing is you're taking one slice of this, so one slice, which is pi r squared, and you're multiplying it by the height. So if we were to do the same thing for, say, a rectangular prism, so we've got a rectangle as our base. We could take one slice, one rectangle out of here, which would be, call this length and call this width, and then this is height. What would be the area of this slice? Length times width, and then the height is height. So the volume would be length times width times height, right? So for any right solid, the volume is whatever the area of the base is times the height. So you're just taking a slice, the area of the slice, times the height. Does that make sense? Now this works so long as the base is at a 90-degree angle with the height. Kind of, sorta. So even if I had like a super weird shape here, if I had something that was like, and then I repeated that weird pattern up here, had this super weird pattern, but I told you that, so I told you that this base was like, say, 8 feet squared, and my height was 10 feet. You could find the volume of that super weird shape by just taking the area of the base and multiplying it by the height. So long as this intersects at a right angle. So then what would...
As long as the wall of that is always perpendicular
Yes.
to the base.
So long as it's a right solid, then the volume is the area of the base times the height. So what would be the area, or the volume of this weird shape? 80 feet cubed, right?
Wait, why does it say meter 10 feet?
That's me drawing an arrow to the height.
Oh,
Okay? Now, that's true in general. However, we're in calculus now, so we're going to talk about weird non-right solids. So let's say we have this weird non-right three-dimensional solid here. Like this is a cross-section of a weird non-right three-dimensional solid. Like this is some, I don't know, maybe like an intergalactic worm, and like we made a cross-section of it and we want to find out the volume of it. So nowhere on here is there a 90-degree angle anywhere. So we're going to talk about how we can maybe try to talk about finding the volume of that. This is where calculus comes into the rescue. So essentially what we're going to talk about is we take slices, just like what we did up here, these slices right here, we're going to multiply by the thickness, and add them up. And then each of these slices multiplied by their thickness added up together is going to be the area of the whole thing. So if I take like this slice and make it just real thin, if I find the area of that slice and then move over a little bit, take another slice, find the area of that slice, move over a little bit, take another slice, find the area of that slice, move over a little bit. Does this remind you guys of when we did Riemann sums? Okay. All right.
So is that supposed to be a 3D object?
Yeah, it's my real bad version. So like imagine it like being like, I don't know, like,
Oh, okay, so like the line you have on the left is going to be like the back side of
Yeah.
it? Okay,
yep.
that makes
Okay. So now, just bear with me a tiny bit more. It's going to get a little bit easier after this. So let's say the volume of this thing is going to be equal to the sum of the area, so we'll call this area x sub I, because this is only one piece, and we're going to do like another piece next to it, another piece, another piece. So this I is going to keep changing. We'll do like, this will be the first piece, second piece, third piece, fourth piece. So the area of x sub I times how much we're changing, delta x sub I. I'm not going to have you guys use this formula this time, because we've already used that formula a chapter ago.
What?
We did. Yep, it's the Riemann sum formula. Remember when I, okay, so remember when I gave you,
This class.
yes you did. Remember, yes you did. Remember when I gave you, remember when I gave you this weird thing and I had you cut it up into rectangles?
Yeah.
And you found the left Riemann sum and the right Riemann sum?
Yeah.
This is what you were doing.
Oh, well, I just did like
Nope.
different sizes.
Yeah, no, this is what you were doing.
What's that sign in front of it?
This is sigma, this is sum. You saw this in both Algebra 2 pre-calculus and this year. Don't pretend like you don't know.
No, I've never seen
No,
that.
I saw it like Mrs. Shop's class working on like Excel. Like,
Okay.
an extension.
It means sum. I used it last year.
Fire.
You know,
For like 5 seconds and then you abandoned it.
Ah.
Yeah, so you could go to like the last half of that is after the AXI.
Okay, so this is delta, which means change. So like it's how thick we're making it. Yeah, delta. Delta in math means change. It's how thick we're making it. Okay,
That's how these symbols are stats.
bear with me for like one more second here, okay? You super can. You can. No. This gets easier. Okay. This changes into the integral from a to b of ax dx. All right. We better now?
Not really.
Okay.
Wait,
Whoa. What? Who the? Huh? This is my intergalactic space worm that we would need to find the volume of.
Yeah, it's a worm.
It's my intergalactic space worm.
okay, so integral.
Okay, the integral.
Right? That's our new formula?
Yes. Good. No. Yes. Bear with me. It's because we transitioned to a new book. Okay, just bear with me. We got like one more example. We're gonna.
What's the letters for that thingy?
Here. That's AXI. Okay. So let me go over one example with you guys. We'll jump to your assignment. It's not that bad. I promise you it's not that bad. No quotations.
Not that bad.
No, flat out not that bad. Okay.
Not that bad is different from ours.
Like a 6.
Not that bad.
All right, so I'm going to draw an XYZ coordinate plane here.
Pretty bad, man.
That's like a 10 is that black hole in the center.
Like a 6. So I'm going to draw an XYZ coordinate plane here, all right? So, right. You can. I don't care.
What the heck?
I'm gonna just give me a second here. Jeez.
I struggle drawing a rectangular box.
What's rectangular? Yeah, I did.
I got it. Here we go. I feel
He is.
Well, I'm trying to make it look like it's supposed to look. Okay. Okay. Yes. I'm a math teacher. I'm not an artist.
I was
Good.
actually like in awe about how pretty it is, but alright. I don't know.
No, which part? Oh, so.
Yeah, that was terrible.
This is right though.
Mm-hmm. I just like this will be the z-axis. This will be the y-axis. I just kind of rotated it.
Why does it, what does it change?
It doesn't change anything. Just bear with me.
Okay. So which one's the, can you label your axis?
I absolutely will. So this time the z-axis is coming out towards you this way. All right.
What do you use 4 on the line? So would it be 4 on both the x and
I think so. Let's see if I put in 4 for x. 8 plus 4. Oh yeah, no, that's super wrong. But so this shouldn't be 4. This should be something else.
So did it go, you put in the y as 4?
Yeah, no, the y should be 4. You're right. You did it in pen. How dare I make you change something? It'll be fine. Just don't worry.
Are you trying to figure out what X is?
No, it's okay. We're just gonna go out to 4 here. It's gonna be okay. We're fine.
So that's 4.
Yeah. Yes. We're fine.
And then 4 is at the top of the, on the y-axis?
Yes. And then I'm just gonna make one more adjustment here.
What's
M-
the letter at the
It's
bottom?
gonna be negative 1 half.
This is a Z. Okay. All right.
I thought you said this wasn't that bad.
It's not. It's super not.
Yet we spent 5 minutes drawing the graph.
I know. Because you guys don't have very much experience with three-dimensional things, which is fine. It just takes a second.
And you put 4 in
So what you found the area of
Yeah, so we're going to take a slice.
multiplied by z?
So we're going to take a slice here, okay? So if I were to take a slice right here, so imagine this slice right there. What shape is it?
Why can't we do it the other way?
It's a rectangle, right?
Yep.
So if I were to take,
Please release the junior high boys basketball team.
if I were to take any slice all the way down, what shapes are they going to be?
rectangles.
Rectangles. So any slice from here all the way to the end, any one individual slice is always going to be a rectangle. What's the formula for the area of a rectangle? Length times
You
height.
make those lines where you're, until your rectangle connects, is that like another rectangular prism? So are the lines supposed to be like plastic? Is that why you did that like that?
Yeah.
Like where you put them right there?
Yeah, and I'm going to add one more thing here. I'm just going to say that this down here is 3 on the z-axis. Okay.
Why can't we just take the y-x plane base and multiply it by the length?
Because of the curve?
So then you'll just take,
So we're going to take the area of the slice.
and then multiply it by 3.
Right. So right now, this is 3 here, so the base is 3. And the height isn't 4, because the height is going to change, because the height here isn't always going to be 4. The height is going to be based on this equation right there. So like the height here is going to be based on what that equation is. So it's going to be 3 times negative 1/2 x squared plus 4 dx, and the radical is taken from 0, and we're going to go all the way to 4, even though the whole thing ends before 4. Okay? And now we're just evaluating this integral. And that'll tell us the area of the whole thing. Or not the area, volume, sorry. I misspoke. The volume of the whole thing. Alright. So now, I'm going to simplify this by multiplying this whole thing out. So this is negative 3 halves x squared plus 12 dx. Integral is still going from 0 to 4. Now I just need to do the antiderivative. So, this is going to be negative x cubed over 2 plus 12x. And I'm going to evaluate it from 0 to 4. Did I lose anybody?
No.
Okay. Negative 6 4 over 2 plus 4 8. And Mr. Taft made a mistake because this goes way far down there.
What?
Okay. I'm going to change one more thing. Some of you are writing your notes with pen. I know. I'm dumb. Yell at me as much as you want to. So instead of going to 4, we're going to go to 3 here. I'm sorry, Maria. Hey, Maria. sorry. Hey, over here. I'm sorry. Okay, so then this is going to be negative 13.5, 48. And then it's going to be minus 0. Oh, sorry, 36, yeah. Sorry, say that again?
Okay, where did you get 36 from?
Yeah,
You put a 3.
I changed it to 3 because if I put it at 4, this actually extends way far beneath the x-axis, which means we're going to have a negative volume to deal with.
But
And that would be
changed
way,
it to 3.
Yep,
It's still,
there's still a negative volume to deal with.
Oh,
There's still a negative,
why is there still a negative volume?
because this point of intersection on the x-axis, if I were to put 0 in for x, so negative 1/2 x squared plus 4 equals 0. Negative 1/2 x squared equals 4. X squared equals 8. That equals x squared equals 8. 2.
That's positive.
This is negative 4. Because I made a mistake. So it should be 2 root 2. I was just trying to make our lives a little bit easier. By using 3, because 2 root 2 is 2.8. And so I used 3 as an estimate. So I was trying to make our lives a tiny bit easier.
okay.
But if you want to use 2 root 2, When
I
I-
didn't see your reason.
I didn't want to use one directly from your homework. In hindsight, I should have done that. In the future, I will do that.
So when you add 36 and 13.5,
22.5?
Yep.
And then that's units cubed, and that would be the volume of the shape. So since I didn't do one from your homework for our notes, I might as well just go over one of the ones from your homework with you.
okay. 2.5 units cubed.
I thought you said that was one from our homework.
No, it's similar to one, but it isn't one. So your assignment is, okay, for the 2 books that I had in here, I added chapter 5, parts 1 and 2. There are books that weren't in here though, and so I have parts of chapter 5 ready to add to them. So if you had one of the books over the weekend, it's fine, unless it's the flexi ones. I can't add it to the flexi ones.
You want to do flexi one?
So what I can do for the flexi ones is I could probably do another flexi ones.
Flexi one, that's perfect.
I know, the flexi ones I like too. So I like the flexi ones too, but I would just have to go like new flexi ones maybe.
Is that tab where the homework is?
That tab is where chapter 5 begins, so that you like know where to go to for the chapter 5 stuff. And then you can maybe move it like as we move through chapter 5. If any want. I'm not telling you how to do your job. So I guess I can just give you no, you have a flexi book too.
Well, what books are those back then?
They're non-flexi, but they have chapter 5 in them.
I've heard of
So I'll make more flexi ones, I guess.
No.
So, okay,
Not really.
Besides doing your.
let's take a look at,
I tried taking notes.
yeah. So the assignment is chapter 5, page 10. We're going to look at numbers 1 through 12 for tonight.
For the rest of the quarter. Oh, this is the last time we do that. Don't even know why I had to.
So I'm just going to kind of walk through the first 6. I'm not going to go over answers to them. The first 6 should be fine. But let's jump and look at, so I'll walk through the first 6, and then let's take a look at number 8, maybe. So starts on chapter 5, the pages renumber, and so we're looking at number 10. So let me just explain how to do questions 1, 2, 3, 4, 5, and 6. Because they're a little strangely worded. So, okay, how you do question number 1. So what it's telling you with question number 1 is box 1, which is this set of boxes down here. You're finding the total area of all those. So box 1 has a base of 5, height of 6, thickness of 1. So you're finding the volume of box 1. Then you're going to find the volume of box 2 and the volume of box 3, add them up, and that's going to be your answer for question number 1. Does that make sense? And then this is going to be your answer for question number 2. And so like this is box 1, box 2, box 3, box 4. Now for question number 3, this is disk 1, disk 2, and then this is disk 3. Your answer, if you could leave your answer in terms of pi, oops, sorry, disk 1, disk 2, and disk 3, if you could leave your answer in terms of pi, that would be awesome. When they say height for number 4, what they really mean is diameter. So when they say height is 8, they really mean diameter is 8. Okay?
So what do they mean by base? Or,
On number 1?
I thought they went the other direction, so I was confused.
Oh, do you need?
No,
Or-
like I thought it went 1, 2, 3
Yeah, they
down.
don't
and
know.
then-
I'll give you this one in a second.
Okay, I totally was paying attention, so I was trying to find it. So.
Okay, I'll give you this one in a second. On number 5, okay, so in number 5, it's this. So they tell you the face area and the thickness. So it's that weird shape, so you just have to find the area of each one. Number 6, so like what's going on with number 6 is it tells you the face area and the thickness. The min area is, so like that's the area of the dark part, that's what you're taking out. So like you'll do 4 times 0.6 to get the volume of the entire thing. And then you'll subtract from it 1 times 0.6. So you'll do 4 times 0.6, which is 2.4, and then you'll subtract from it 1 times 0.6 to give you 1.8, and that'll be the volume of this disk. And then, and then this one you'll do 12 times 0.6, and you'll subtract from it 1 times 0.6, and then you'll add all those up. Does that make sense? All right, so let's take a look at question number 7 here. Or not 7, let's do 8. So let's do 8.
Alright, did you upload that to the?
Not yet, but I will.
I think it's still recording.
It is recording. Actually, let me upload it right now, really quickly. Sadie, I'll upload it right now.
I don't even know where to go over there.
Classroom, or not Classroom, it's sites.google.com. Mr. Taft's calculus. Dismiss. And then textbook. And I'm going to add files. 3, 4, 5. Okay. So, Sadie, if you go to my website, on the textbook link, it's 5.1. It's cc_5_1_ So the site is what is it again? So this is my version of it. Roundup.k12.mt.us. Wait, no, is that it?
Yeah.
Roundup.k12.mt.us.
No, it's
Oh, sites.google.com /a/roundup.k12.mt.us/calculus. Okay, anyway,
Is it just units on these, Mr. Taft?
yes. So let's look at question number 7.
So is there a specific answer for whether or not time matters in?
It doesn't.
Okay.
However, The only argument I would accept where time really did matter is if you're saying that, like, by running. Well, I mean, I do accept that clothing thing because I hadn't thought about that. If you're running, you have a different shape, and that might affect the surface area. That is something I thought about.
So what about if you're at a dead stop?
If you're at a dead stop, then you're not moving, and you're not going to collect any of it.